VTP, once again, does not send updates across access ports. So new ports in this example, such as this interface and this interface, will not transmit VTP messages because on these switches, the default DTP mode is dynamic access. On this port, I configured dynamic desirable. Here we configured VTP statically. I configured VTP statically on this link, but this side is using DTP. It's good practice to set it the same on both sides, but I'm just trying to show you different scenarios here that you may encounter. And to show you another example, we'll configure switch 4 to use VTP transparent mode. So let's start up switch 4. It shouldn't learn the domains because on gigabit 02, it's using dynamic order. And on switch 2, show interface gigabit 01 switch port, it's also using dynamic order. Be careful, however, as mentioned, a lot of switches have dynamic desirable as their default mode, so they will automatically form a trunk with a new switch. And if that switch hasn't been configured with the VTP domain, the switch will automatically learn the VTP domain and synchronize. So here is switch 4, just boot it up, hostname switch 4, show VTP status. No domain was configured, it's null, but the switch hasn't learnt any VLANs. Notice the configuration revision number is 0, show VLAN brief. The switch only has the default VLANs configured. So what I'll do now is change the mode to transparent. Show VTP status. The domain is still null, but the mode is transparent. So to make the point, I'll set the domain to CCNA, the same as the other switches. So VTP domain CCNA. You can see the domain name is changed. Show VTP status. Domain name is CCNA, same as the other switches, but it's using transparent mode. Let's set up dynamic desirable on gigabit 02 and 01. So switch port trunk encapsulation.1q, switch port mode dynamic desirable, do show run interface gigabit 00. I'll copy those two commands to gigabit 02. So show interfaces trunk. We've got two trunk interfaces configured, gigabit 00 and gigabit 02. Show VTP status. Notice the configuration revision number is still 0. Number of VLANs configured is still 5. Show VLAN brief. Switch still only has the default VLANs. So if we configured another VLAN on the switch, let's say 10, and let's say 11, show VTP status. Configuration revision number is still 0. But we have VLAN 10 and VLAN 11 in the database. These switches, show VLAN brief, have not learnt about VLAN 10 and 11, and that's because this is a transparent switch. A transparent VTP switch does not update or synchronize with other VTP switches. Servers and clients do synchronize with each other. Servers can create VLANs, clients cannot. Transparent switches can create VLANs, but they don't synchronize with other switches. So essentially, what VTP transparent mode does is turn off VTP. If, however, I changed the VTP mode here to client, what happens now? Show VTP status. Suddenly, the configuration revision number has changed, and the VLAN database has been synchronized. Note the difference. VLAN 10 and 11 have been removed. This client synchronized to the server, because it had a lower revision number. The revision number was 0 when I added it to the database. But be careful now. If I shut down these interfaces, gigabit 00 and gigabit 02, so I've shut down both these interfaces. And now what I do is make this a server. So let's say it's a server and it's in a lab. And then I do something like this. Remove VLANs 2, 3, 4, 5, 6, 7, 8, 9. And then create VLAN 10 and 11. In the VLAN database, we only have VLAN 10 and 11. But notice what's going to happen. Show VTP status. The configuration revision of this switch is 20. The configuration revision of the rest of the network is 10. When I change this to a client, the VTP configuration revision number doesn't change. So a client, in this example, has a higher configuration revision number than the rest of the network. It's a misconception that people believe that when you add a new switch to a topology, that you just have to add it as a client. This is what happens when you do that. I'll no-shut one of the gigabit ports down. Show VLAN brief. VLANs are still set to 2 to 9. Interface is still coming up, so show interface trunk. Trunk is now being negotiated. Notice now what happens to all the VLANs. All other VLANs have been removed. The only VLANs in the VLAN database now are 10 and 11 that we added on the client, as well as the default VLANs. Be careful. A client can override servers if it has a higher revision number. What you should do when you add a new switch to the network is you should set it to transparent mode after you've made all your changes, such as deleting the VLANs, because the VTP configuration revision is set to 0. And now change it to a client and add it to the network so it can learn the latest information from the rest of the network. Notice previously the configuration revision number was 0 and now it's gone to 20. But that's a bit late now because we've deleted all other VLANs in our network. So the moral of the story is VTP synchronizes between servers and clients. Transparent switches don't synchronize. Be very careful adding a new switch to the network. If it has a later revision number, it will simply update the VLAN database of the rest of the network, which may mean that some VLANs are removed, which can cause problems. You should set your switch to transparent mode and then to client mode before adding it to the network.